All right, good afternoon, everybody. Hope we've all had a little chance to digest lunch and get started. We'll wind up the propeller beanies a little bit on this talk. So I'm Bruce Wilson. I work at Oak Ridge National Laboratory. When we started this effort, I was one of the enterprise architects. I'm fortunate that I actually happen to be the CTO for IT at Oak Ridge as of a couple of months ago. JT Liso is a student at UT Knoxville. Much of the code that's here is stuff that he's written. So if you like what you've seen, it's his. If we screwed up, it's my fault. Coordinates are up there. There's a little bit of some background. I am by original training a chemist. This is the first time that I've had the chance to speak at a cybersecurity conference. So let's have some fun and walk through. I will riff off topic for just a half second on Amanda's topic at the keynote this morning. And I was reminded that when we look at others, we tend to see their highlight reel. And when we look at ourselves, we see our outtakes. I will simply say Amanda commented that she was 25 before she realized she needed some help. I was 45 before I realized I needed some help. Moving back on topic, SAML. What is it? How does it work? That's the first piece. We'll talk about some of the attack vectors and things that we need to look at and that are behind this test, the testing framework that we've developed, and the test results. So SAML, Security Assertion Markup Language. This is a broadly used protocol for logging into websites using employer or university credentials. It enables a single sign-on. So, for example, ORNL uses ServiceNow. I suspect a lot of folks do. I log into ServiceNow using my ORNL credentials. That's done through SAML to pass that information on. And it is a useful tool because it involves letting the user in, but we don't have to do things like, say, replicate usernames and passwords out there. As we step things up and implement, say, multi-factor authentication internally, everything that comes out of our SAML IDP benefits from that. It is based on XML, which is at least signed and in some cases potentially encrypted. And if anybody's familiar with SOAP as a process, that tends to be somewhat complicated. That's a word that gets my attention because complicated software, certificates, there be dragons. So what kind of dragons and what motivated this work? What first got my attention was there was a paper published in 2012, the citation is there, that they found a significant number of flaws in 14 different SAML service provider packages, including Shibboleth. That should scare people because Shibboleth is by far and away the most widely used SAML service provider basically by every single university in the country. It is the primary open source provider. Now, Shibboleth has fixed those problems, but that still gets one concerned. OAuth is related. OAuth is a similar process often used in a number of mobile applications. And this is a Black Hat paper from 2016. They found that 41% of applications did not implement OAuth correctly and were susceptible to impersonation attacks. So let's dig into this and see what we can find. So a couple of key terms. I've used one of them, the service provider. That's the website that the user is trying to log into. If you're used to looking at Kerberos or OAuth, they'll talk about it as the relying party. If you are, like me, fortunate enough to have to work with things like NIST 800-63 as standards for authentication, they will also talk about the relying party. The identity provider, that's the thing that is validating the user's credentials, and it is, for us, we happen to use PingFed. Many people might use Active Directory Federation Services, ADFS. That would be the identity provider. So let's dive in a little bit. There it is. There's SAML. Perfectly obvious, right? Yeah, you can go cross-eyed looking at it. I will dig into what some of this is. If you go to Wikipedia, this is the diagram that they put for what happens in a SAML transaction. And I find this is one of these things that once I understood what the heck SAML was doing, this made sense. But it didn't make a lot of sense to me until I actually started to dig through and watch what was happening in a SAML transaction. So let's walk through it. There's a couple of things I want to point out with this. So we have a pre-setup here. So this is a step typically taken by a human that we are saying we're going to have this service provider, and I'm using sp.example.com here. These are the identity provider systems here, and this is a PCV, a password credential validator in this case. Think, for example, something like Active Directory or LDAP, but it's the thing that the SAML software is going to call. SAML is based on public key crypto, asymmetric cryptography, if you will. So the thing that you have to do is you have to tell the service provider what is the public key that the IDP, the SAML software, is using. You might go the other direction as well, and this is essential, of course, if we're doing the encrypted forms of SAML, and give the public key for the service provider to the IDP. This is done out of band. For those of you who are familiar with InCommon, that provides a central trusted repository for this information. But most of the time, this is an administrator who has access to both systems and is moving some keys around. So we start with a user. And in this case, I'm looking at a user who happens to be on our internal network. And I'll talk about some of this a little bit later. And that user talks out to the internet and says, I want to go to this particular page on you, Mr. Service Provider, or Ms. Service provider then asks the question, does this user have a valid session with me at this point? Great. If we do, then they can use it. No. Well, where am I supposed to send this user? And there's a couple of different patterns that happens with. And that's what they talk about as IDP discovery. But in this case, we're talking about SP. So it knows that this should send this user to the ORNL's provider. So here it is. So it's going to give the user a SAML request, which is a blob of XML, and a relay state. And the whole point here is the relay state is the means by which the service provider will remember later where that user needs to go. The user then goes to that identity provider and says, here's my SAML request, here's my relay state, I want to log in. The SAML software can then be asking questions, does this user already have a session with me? Well, let's say no. So now we need to do a credential validation step. Hand the credential back to the SAML software that then talks to a credential validator. Let's assume for the moment then that credential is valid. Now then the SAML software, and in this case is going back to the same place, but it could go someplace else, goes to pick up attributes about the user. So in the case that I'm simulating here, I would be logging in with an internal username and password, but my username off here in sp.example.com happens to be my email address. So the SAML software then needs to talk and get that information. It's got it. It will then look up the information that it had, the SAML requests, the relay state, assemble all of that into a SAML response. That's the thing that we're going to talk a little bit more about. And it sends that SAML response and the relay state back to the user, who then sends all of that stuff back to the service provider. The service provider then needs to take a look at all of that information, say, is this a valid SAML token? Is this user somebody who should have access? And a bunch of other checks. And if all of those checks pass, then it gives the user a session cookie for talking to it. And then the user can move on and do what needs to happen. So some notes about this. Number one, there are multiple different ways of doing SAML. What I'm talking about here is what's called a post or redirect binding, also called a bearer token. This is the most commonly used method of doing SAML, and potentially the least secure, but okay. Those two things often go together. But what happened here? Everything which is important went through probably one of the most hostile territories around, the user's browser. So what can be done with that information? Well, we can encrypt the SAML payload. That's not often done for a variety of reasons, but it's absolutely done if we're passing sensitive information through the user's browser. There is another more secure method. This is called an artifact binding, so that what I send back in that SAML response is a nonce, and then the SAML service provider needs to then talk back, and it will get all of its information through that back channel. And this is how OAuth is often done. But that also then requires some things. If you noticed in my diagram, my identity provider was buried down in the internal network. There's a reason for that, because in that particular configuration with what I'm doing, my identity provider is not internet exposed. This is one of my means of protecting this asset to only allow access from people who are legitimately on the ORNL network. It's one form of authentication into the service. So artifact binding is useful in some cases, but can't always be used. So digging into this, there is a lot that is buried in this one box. And in particular, if any folks have done signed messages, if you've done asymmetric cryptography, it's easy to make mistakes. So let's dig into what that SP should be doing and ask some questions about how can we test. I mentioned Samarovsky's paper. That was the 2012. We went to look for their code. It was written in Java, which is not my particular language of choice. And it looked to be largely abandoned. I think this was somebody's master's thesis, and that student then went off to a real job, and the code was abandoned. JT and I had been working on some testing of our existing infrastructure tools, some synthetic transactions, and we've been using Cucumber, which I will talk to about in a minute. It's a domain-specific language for writing tests. It's got this great interface with Watir WebDriver, so great, except that Watir didn't help for reasons that I'll talk about. But, you know, we've got the pieces parts. This shouldn't be too hard. As usual, there's an XKCD for that. So more time later than I expected, we actually got to the point, and so this actually is the way the test appears. This is a simple test that I will dig into. In this case, what we're doing is simulating or is testing whether or not the service provider will accept unsigned SAML. Again, SAML should always be signed, because if I'm not sending a signature through and I'm going through the user's browser, then an impersonation attack becomes trivial. So, what can we test? Does the service provider validate the signature? And the common way that we do that is we change the SAML subject, which is effectively the username in this transaction. Does the service provider handle a supplied public key correctly? I can put a public key in that SAML message to say, this is the certificate I'm using. That should tell the service provider to go, that's the key to use out of the list, and this is used for rolling keys. So if I'm signing with one key and now I've gotten a new key because my old one is expiring, I send in the SAML message, I'm using the new key or I'm using the old key. The service provider shouldn't actually say, oh, that's the key you want to use? Great, that's fine. That was actually some of what Samarovsky found, and that's why I put that test in this list. Does the service provider fail completely if the signature is stripped out? The service provider should never, ever, ever accept unsigned SAML. That was, again, part of the problems that Samarovsky found in their paper. This is the one problem that we found. That was due to a configuration error. And the SAML should time out. So a SAML token should be valid for a period of minutes. This is configurable in the setup between the service provider and the IDP. It does require that they are using a common clock. A fairly standard setting is that a SAML token is valid for 5 minutes. That accounts for an awful lot of clock skew. We actually often use a 3-minute timeout. You may be aware that there has been some pre-compute attacks against SHA-1. those still are not things that are feasible to do in this context in under a few minutes. So that's an important feature within SAML and some of these other tools. We have not yet put in the framework to be able to do testing of replay attacks. A SAML token should be valid exactly once. That was a problem that Samarowski noted in a few places as well. We are not presently doing anything with encrypted payloads, nor are we doing anything against the artifact binding, nor have we got anything working today. Like a lot of folks, we are doing more and more with multi-factor authentication. Scripted tests involving MFA or, yeah.
So what kind of tests would you do with encrypted payloads?
Part of what I would try to do is reverse the encryption. Again, a knowledgeable attacker who happens to be have knowledge of the encrypted mechanism. You can do encryption a couple of different ways. You can encrypt the entire payload. You can encrypt certain fields. And so what are the capabilities, for example, to replace that field with an unencrypted? That should cause something to fail. If I synthesize a transaction, or if I've got the public key for the service provider from some other means. In many cases, that public key is available. So for in common, I could get the public key. Let me substitute something else into that SAML transaction, and again, make sure that that should fail properly. If I'm doing something where I'm working with a service provider and I want to strip out the SAML signature, for example, and then encrypt, that would be one of the kinds of attacks that we could envision. And we have not played at all with the SAML request, the piece that comes from the service provider.
That's different than the entire connection being SSL.
The entire connection will be under TLS. I can't think of anything that we're doing. So everything is done over HTTPS, but you're also doing an encrypted payload inside of the TLS tunnel.
Yes.
What about are there any setups where you're doing, you're not using username and password for authentication, you're using another certificate for authentication?
We are, and some of the code that you'll see, so we actually do use internally Kerberos tokens for authentication. We have a number of connections that will do certificate-based authentication, PIV card for those that are used to working in the federal government space, or RSA token or other out-of-band authentications. The problem is it's difficult to make those work inside of a scripted test. So we've been working primarily with things that are using usernames and passwords today because it's an easier problem and that covers some of what we're doing. We do have the Kerberos piece working.
You should, if it's a time series code, you should be able to use cucumbers built on top of Ruby. You should be able to include a gem that actually is a number provider. And so you register that as the one-time token for the account that is being tested.
I can, except for the fact that all of the one-time password token generators that we use are hardware-based. I don't have access to the seeds. There's some advantages and disadvantages in working in a paranoid environment. Or just because you're paranoid doesn't mean they aren't out to get you. So test results. We tested all of our sensitive internal and external SAML providers. We did find one configuration error that led to unsigned SAML. It was on a dev site, right? Actually, what happened in this particular case, and I'm not talking about the vendor, because it's still under investigation, we did an upgrade of that vendor's cloud software, or when they provided the update. So we told them when that could happen in that environment. And in the process of doing that update, for some reason, it all of a sudden started accepting unsigned SAML. Shouldn't have happened, and that actually did lead to the understanding that this is actually something that we want to include in a regression testing environment. But I did actually have something. Well, it was just a dev site, so it's not a problem, right? Yeah. The other thing that was interesting out of all of this is, as is appropriate, when we were working with an external company and attempting to test SAML, we spoke with their security groups beforehand and said, hey, we want to be running this test from this IP. This is what we're going to do. Great, fine. One of the people that I spoke with said, great, thank you very much. I'd like you to be very noisy when you do this, because I want to see if our SOC picks it up. They didn't. So in fact, none of the service providers that we worked with actually came back to us and said, we were detecting this unusual activity coming from your network. The kinds of things that we were doing are more likely indications of adversarial action. They could be indications of misconfiguration, particularly unsigned SAML. That could be a configuration error. So I think this is something that is worth...
How would that manifest for the providers? How would that manifest for the providers?
The provider would see invalid SAML coming in. So they would see something where SAML signature failed, no signature present. The software that we're using, I see all of that in our logs. And it is something that has caused me to ask some questions of our SOC in terms of some alerts that we might want to come in, look at for things where we ourselves are the SP and we're looking with external service providers. But it's one of those things that it did cause me to go, I kind of would have expected a little bit more of a response. So there's some things that we learned. JT has a very bloody forehead at a point in time trying to get what's here to not follow redirects. So part of what is going on here is there is a tremendous amount of redirects that happens in all of this. Some of these are HTTP 301 redirects. Others of these are redirects occurring in JavaScript or in headers. And they differ at different stages and using different software. So we wound up falling back to a much more primitive method of using REST clients in Ruby to do this. And you have to be careful about how you manage the cookies because you just need to, and that led us to some false positives and false negatives. The other thing that is interesting, and this would be fun for an ongoing discussion if anybody is interested in digging into this. We've gotten some things to work. But the code is not as well abstracted as I would like. I would like for this to be much more generalizable than it is today. And so folks who have suggestions on that would be appreciated. And you'll see some of this as I dig into the next sections to talk about how did we get here. I mentioned Cucumber, an open source domain-specific language. You saw what it looks like, absolutely built on top of Ruby. If you are working with SAML, I strongly suggest that you get the SAML tracer as a Firefox plugin. This lets you see all of the details. The SAML request and SAML response are actually transmitted as base64 encoded strings in post typically, and SAML tracer handles all of the base64 decrypt. You actually get to look at those things. You also get to see all of the other post variables. Oh, by the way, watch, because if you're doing usernames and passwords in your post for password credential validator, those will be in the SAML tracer logs. Like I said already, framework for testing. And we had some in-house tools for credential tests. I will mention that. A good password vault would be a better answer than some of what we've done. I will also say that Thomas Edison, when he was asked about what he had learned after 500 experiments trying to make a light bulb, said, I now know 500 ways to not make a light bulb. We had several of that, and of course, Stack Overflow was an essential element to getting to where we got to. Yeah. So I mentioned here is the sample test, and I want to walk through what this looks like. So, for example, this given my testing default credential, what this let us do is, with a little bit of setup, JT can be running the test, and he's running under his credential, his username. I can run the same test, and I'm running under my username. In a few cases, we can use testing accounts. But in a lot of the systems, like our internal SAP environment, where we were trying to test it, you actually have to test some of these things from a real account. And we actually have some rules designed to prevent problems that actually make creating synthetic accounts problematic. Snake biting his own tail. So that looks something like this. Test cred is a Ruby script. It stores the usernames and passwords in a encrypted location off of one's home directory. That way, if I name it, my testing default credential, and he names it testing default, the script actually works and it pulls up his user ID or pulls up mine. The main reason that I started this is because I have made the stupid mistake more than once, unfortunately, of putting my credentials into the Git repository and then having to fix history.
What do you mean, Git's not a username and password repo?
Yeah. So, a true, a CyberArk or something else like that, plug for a vendor out there, we don't use them, but I like them, would be one way to actually store those testing credentials, LastPass Enterprise or some of the other tools. But this works, and good enough for present purposes. So we did have to do some retry stuff, and I put in there's a service provider initiated URL at the start in the transaction. This might look like something like ornl.sp.servicenow. Or ornl.sp.example.com. It actually is ornl.servicenow.com for using that, but I just didn't want that in the slides.
The video is fine.
Yeah, I know. But it's not text searchable yet.
That's what the automatic transcription is.
Exactly. But can they understand my Tennessee accent?
What accent?
Exactly. So we have this in the retry, and part of this was in place because, like I said, we actually do use Kerberos internally, and some of these things are doing the standard Kerberos dance of, hey, you got a Kerberos token? No. Hey, you got a Kerberos token? No. And you have to do that a couple of times before it says, okay, fine, I give up. I'll present you with the username and password stuff, and then all of the redirects that one follows to get through. So we can specify a retry limit, and we're looping through if we're getting 301 redirects or if we know we need to parse through, and we do put a limit on that. This is an area where I would love to talk to some folks that are better developers than I am about how to take this and abstract this out. So we did have to put in some things that were fairly specific to some of the web forms that we use for collecting credentials and some of the idiosyncrasies. I toyed around with some of this a little bit with a shibboleth installation, and we would actually have to make some fairly major changes to code if we were using SHIB or using ADFS as the identity provider. But that does lead into some of this code, and the way we phrased it was to try to allow for being able to substitute out, this is an ADFS form that you have to parse instead of a ping-fed form. And, by the way, this is where you have to stuff the username and password in for this kind of a thing to pass it on. And you can see that's where that's getting that username and password out of the test cred. We wanted to put together some different ways to say what was successful. So these are examples of, if I go through all of this, I'm going to specify that the resulting page should include some information. I should have some specific HTTP status codes, and that's basically collecting up that and what amounts to a set of expects that get saved. So now this is where we have fun. We've got to follow the redirect to the point where we get the SAML response back from the IDP, which actually is, again, a little bit more following of redirects, some of which are buried inside of JavaScript and some of which are 301s. And then we get to the point, now we actually want to have fun. Let's strip out the SAML signature. Great, we've got all the tools to do that. So this is now actually the easy part. The hard part is actually getting to the place where we have a SAML response that we can play with. And we basically take that SAML response. Here's that whole gibberish. Here's the piece that we care about. This is what the XML looks like for a SAML signature inside of that. And we basically say, you, go away. Strip that out of the XML. Nokogiri makes that really easy to do. And we then submit that SAML response, and the success criteria should fail. Now, again, the way we do this is part of a script that we start with a, SAML breaker does nothing. All of the success criteria should pass. Then we walk through in that test script and apply some of these changes selectively, and the test should then fail. And then I have, at least in some cases, then recreated the block at the end that says SAML tracer does nothing, and the success criteria should all pass as well. And we get something that looks like that. It's sending all of the stuff on to the service provider, and then walks through the tests and makes sure that if we're mucking with the SAML, at least one of the tests should fail. We do have some ability to capture the output. We've structured this so that if we set a debug level, we're actually capturing all of the HTML that we get back in response, storing that off into a log file that's time-stamped with that particular run, and so forth. So where we are with this is there's some code cleanup that we need to do. The intent is to put this out on GitHub. I have not done that yet. That's mostly a matter of what we have still needs a little bit more cleanup, and I'd like to try to make sure of how do we put out some things that describe actually useful tests without giving away too much operational security information. That turns out to be a little bit more difficult, but I will be publishing some tests probably that go against testshib.org. I have some permission from those people to be able to put out that as a real test. Would love to, again, put that out to the community, let some of the brighter minds out there take a look and say, oh, well, if you would just think about this way, then that simplifies all of your tests. Thank you. Things are often much more obvious to somebody else looking at the code than those of us that write it. And then the last thing is actually an interesting challenge, because in doing some of this digging, there's a session hijack risk that intrigues me. And part of this was demonstrated by the fact that I would do something like, for example, get onto our corporate VPN and use that to get onto one of the external sites that is validating against the internal identity provider. So I can only do that from within the VPN environment. But now once I establish that authentication and I drop the VPN, I still have a valid session cookie back to that service provider. So that says, oh, there are some interesting possibilities here with session hijacking. What happens if I have an endpoint which is owned? What is the adversary actually able to do in order to grab that session credential and now take that someplace else and replay that session credential to obtain access into that cloud environment in a way which I am potentially blind to? I will tell you that working with a variety of cloud providers, there is a wide range of one's ability to be able to get logs back from the cloud provider about who has been doing what. I will call out one vendor as the exemplar of that. I work with Dropbox on a regular basis. The logs that we get back from Dropbox, in my opinion, set the standard for the kinds of things that I would like to be able to get back from a cloud provider. We put a hold for about 12 months on a deployment of migration to Office 365, because at that point in time, one of the significant weaknesses in O365 was that we could only get logs back from them at a higher level than we would like, 12 hours in arrears. But this then leads to that question of, if somebody's doing this, they can potentially replay that session cookie into the cloud from someplace else where I have no information, and if I can't get information back from the cloud provider about who is doing what, I'm blind to an attack that I would really rather not be. So that's the currently active area of investigation, is how do we take and in a more general fashion abstract out how these logs are managed, what are the logs that we're getting back from the various service providers, and hook them into the logs that are from our identity provider. And I should see an authentication event internally for every access externally.
How long do those normally time out?
It is service provider by service provider specific. I know that when we started with ServiceNow, for example, their default was 30 minutes. We've increased that to somewhat longer. I know there are some service providers that we work with for low confidentiality that it's a couple of days. We typically do no longer than a half a day for anything sensitive, and we're reevaluating. If we can get the mitigating controls of seeing what's happening, we're willing to go to longer timeouts. If we can't, then we'll have to go with some shorter timeouts.
I'm not familiar with SAML as much, because we almost universally use OAuth too. Does SAML support detailing what remote host the token is valid for as part of the signed payload?
So the question is whether SAML supports detailing the remote host and where it's valid for. It does not in the sense of the SAML specification. That would be an implementation specific issue.
Once you do the authentication, it's not going to...
Right, the question is, in this situation, does he desire to allow the authentication to cross out of his private network boundary into just a random internet host boundary?
Right. And we can do, well, that gets,
Because that's the
yeah. We've got a few minutes, so I'm going to dive into where that gets complicated is that if anybody is using direct access on Windows systems, direct access if you set it up the way Microsoft recommends, it's a split tunnel VPN. So my IDP sees an internal address. The service provider actually sees my home address. So that complicates that question. Yes, I can set up some things, and for example, we do have some AWS instances, for example, where it will only permit authentication from our IP address range, period. And so you can't get in there from just a general. But that's not anything that's in the SAML specification itself. Other questions? Okay. We're done a little bit early. Go enjoy the hallway track. Go enjoy conversations, and I'll hang around for a minute if there are. Thank you.